And thank you everybody for joining me today. And I just, before I start, I actually just want to talk a little bit about how valuable I feel like NumFOCUS and the whole PyData community has been over the last few years, and like building very community-centric events in regional areas, and just like kind of creating an opportunity for data scientists and machine learning experts to kind of get together and talk about these things. And so, a big thanks to them for putting on these events. We've been doing them in Berlin, Amsterdam, Seattle. And I'm super excited to be invited to speak here and to kind of give all this commentary. So, thanks to PyData. And so this talk is going to be about building an expert question and answer chatbot with open source tools and LLMs. And to start off, I wanted to just kind of like talk a little bit about the audience this talk is geared towards. And so we're assuming that you have experience working with Python and working with some of these applications. But the talk itself is going to go a little bit deeper into, it assumes an introductory level. So we're going to cover some introductory material, and then I have code that we're going to try to run to just like stand up these bots on your own so that you can see actually how easy it is and how a whole wealth of open source tools like LangChain and Gradio and Chroma make it incredibly easy to actually just stand up applications with just very, very few lines of code. And that's going to be like the first part of the talk, is kind of covering these things and getting these basics set up. Then once we get past that point, we're going to talk a little bit about how you improve the performance of these systems based on how they're built. And so this is where we're going to pull in tools like Label Studio so that you have an opportunity to give human feedback and how you can incorporate, again, these tools into your annotation platforms and into your workloads, so that you're not just building bots that you're sending out there, but you can actually build systems that give you an opportunity to go back and interact with them and improve upon their performance. So all of the code is available, as well as the slides. And if you head to this link right here, that's going to take you to the Label Studio homepage, where we have a micro page set up for PyData New York. You'll be able to get the GitHub repository, as well as the slides. And this will be available always. So if you want to follow up after, grab these things, use it with your own stuff, like it's available in there for you to use. There is one thing that is a little bit more difficult. Whenever you're working with LLMs, there's a pretty big question of like, how do you get access to those? And unfortunately, free access is difficult to come by. It's hard to distribute a model because every one of you is running a different machine that may or may not be capable of running a model locally. And so if you start using hosted models, it's very difficult to find one that doesn't require you to have some sort of paid API. So I want to be completely upfront about this, that this talk is also going to require an OpenAI API key. We use GPT 3.5 so that like really keep the costs down. But I want to make you aware of that because this is a non-free service that's being used as part of the talk. And I think it's something that's difficult to overcome right now. We're making a lot of progress in open large language models and other open models being available for broader consumption, but even the hosting is kind of an issue. So I wanted to be upfront and transparent on that before we start. And if this URL is also written up on the board over here, so as we move past the slide, you should be able to go there and start downloading. Okay, so what are we going to do? We're going to be fine-tuning a QA chatbot to answer questions about Label Studio. So we're going to be pulling documentation from GitHub using LangChain, and then building embeddings that are going to go into a vector database using OpenAI, and then we're going to use Gradio to have a bot that is going to answer questions for us. You've probably seen this before, right? This is very popular way of doing things, but if you haven't, then you'll see how easy it is to kind of get started with this. Well, let's start off with an introduction to large language models. If you don't have a lot of experience with LLMs, it's like, you may be wondering, like, you hear this word a lot, what does it mean? And you can almost, LLM stands for large language model. And you can think of it as, there's a library analogy that goes along with this, where you can consider the internet to be a giant library of knowledge. And LLMs are like a library. A librarian that has read every single book in the library. You can ask the librarian anything, and you'll get a response based off of what they've read. Now, the answers may not always be perfect, but typically they're impressive. And one of the goals that we want is that we want to address this idea that they're not perfect, because we know that there's so much knowledge out there, and that some things may be good, some things may be bad. And one of the best ways to identify things that aren't great is to kind of bring human knowledge into the process. So LLMs are trained by kind of this approach of like, guess the next word. Imagine that you're teaching someone to speak, and you read a sentence to them, and they just have to predict the next word. And then based off of that prediction, you give them feedback. And they make corrections on that. Over time, they would begin to recognize the patterns and notice the similarities. And you can think of LLMs as having read billions of sentences, predicting characters as well as words, which is important for coding. And it's using this to learn deep patterns. And you might ask, well, how do the corrections work? Well, LLMs have billions of parameters, and so these models are huge. I think I've read billions to trillions on some of these models. They're absolutely enormous. And a parameter is just like, if you imagine it as a giant mathematical function, every one of these parameters is just like thinking of like if you have a polynomial where you have, a squared plus, ax squared plus bx plus c, right? Those a, b, and c's are parameters, but imagine that there are trillions, billions of these. And you're tuning these. You're just like, you're making small corrections to those. You're giving the input, checking the output. So with each guess, you compare the answers the LLM gave to the answer that you wanted, and you treat that difference like a compass that points in the direction you want to tune the parameters in. It's a method, typically we call it gradient descent, and there are a bunch of different ways that you can do it. But another way to think about it is like you're blindfolded, and you are trying to navigate some terrain. You want to find your way to the bottom of the mountain, and you just always take small steps in the directions that take you down the hill, right? Is another way to think about how this works. The model's adjusted, and the next step is taken, and slowly this landscape of the model takes shape, right? This is all to just give you a bit of context to like how these things work. So LLMs they're winding up being like massively useful. Like 2 years ago, we barely even thought about these things, right? There was some talk of like, some GPT models and the things that they could do, but they've really taken it off this year. And you may have like used, like ChatGPT for any of these things, like writing a resume for yourself, right? Like, oh, help me write a cover letter for a job that I'm applying for, or I need to have some report finished, or just asking questions about general things. And so there's just a massive number of things that you can do. I mean, people even have built games on top of that. But the problem is that this knowledge is general, and domain-specific topics may be misrepresented. LLMs also just don't truly understand, like they're kind of like these general prediction engines. There's a level of inconsistency. You maybe get different answers each time. And most importantly, the knowledge may be out of date, depending upon the data set it was trained on. So for example, like some of the GPT models, like their knowledge ended September 2021. Which means that anything that's happened from that point forward, like, about applications you may be using or world events, may not be true. And a perfect example of this is try asking an LLM what the weather's going to be today, right? It just doesn't know because it hasn't been trained on historic data. There are ways around those problems, but but this is, generally speaking, like the knowledge base that it's trained on is usually fixed at a certain point in time. Okay, with all of this in place, we're going to start thinking about how can we build a QA system, right? And so we have an LLM, and the first thing that we want to do is just build a system that can answer questions. So our goal is we're going to build a chatbot. And in this case, we're going to build a chatbot that can answer questions about Label Studio. Label Studio is an open source data labeling platform that the company I work for makes. But really, in this workshop, I encourage you, if you want to build a chatbot that answers questions about something else, like you can go to any GitHub repository with markdown documentation and tailor the bot for your own purposes. So we're going to be asking ChatGPT about Label Studio, but a lot has happened since 2021. We've had 2 years of development since this was built. So we're going to grab the documentation from GitHub. We're going to help build some context for the chatbot, and help train up the model using this. But how are we going to do this? Well, there are a ton of different ways that you can actually retrain LLMs. Like, the most expensive way is to go in and actually do fine-tuning against the model itself, where you're going in and changing the parameters. It's incredibly expensive and difficult. It takes a lot of resources, and it's quite frankly just not available to everyone. But there are all sorts of techniques that we can use to actually leverage the strengths of large language models that don't require us to go in and completely retrain the whole thing. In the example that we're going to be giving today, we're going to use a technique called retrieval augmented generation. And the idea behind this is that we're going to collect our data set, so in this case, the Label Studio documentation, and then we're going to build what we call a vector database from that data set. The database is going to consist of a mapping between our input strings, which are coming from the documentation, and output vectors, which represent some sort of semantic information about what's in that document. And then we're going to insert these vectors and text into the docs database. And if you don't understand all of these terms, we're going to get into what these mean in the next slides. Then, when we ask the chatbot a question, we're going to convert the question into one of these embeddings. And so we're also going to compute a semantic vector based off of this. We're going to select the top documents that are similar to our question based off of the context. And then we're going to query OpenAI with the OpenAI model with context from the docs and the user query. And then we're going to return you the response. And so we're going to, in some ways, precede the chatbot with information that's related to the question that we're answering so that it can evaluate that also and generate an appropriate response. And in this way, we're kind of like transferring more current knowledge into the large language model as it's generating this text. You may have heard me use that word, embedding in vectors. And what is an embedding exactly? Like how many people like kind of like work with embeddings and understand how they work and they do? So some folks. So if you hear the word embedding, essentially what you are trying to do with it is you're turning lumpy things into the real world, especially like words are really lumpy, into continuous variables. Because large language models, like we're using these large mathematical functions and they're performing operations, doing continuous mathematics against non-continuous things. So you can take a naive mapping of different categories of vectors and numbers, and you can lose meaning. So like one way that you can do an embedding is what's called hotshot embedding, where you just assign a number to a word, right? And so maybe the word cat gets the number 1, and maybe the word chair gets the number 2. And you build up a large mapping of words to numbers, and then you can have your vectors represent that. But as you can tell, like, cat and chair may not have any, like, there may be no relation between the two. And you can try to do more complicated things where you're trying to group things naturally, but it takes a ton of work, and it's not necessarily going to produce the best results. It's a fast way to do it, but it can cause you some problems. So you're better off trying to build some sort of complex mapping that tries to capture semantic meaning from this, and in some sense, like creates a vector where vectors that are close to one another, for the words could have similar meaning, and it helps answer questions like, is a teapot like a dog, or is a dog like a hot dog, or is a hot dog a sandwich? You can imagine that all of these different words in these contexts, there's a distance between them. Like the distance between teapot and dog is very large. The distance between dog and a hot dog is smaller. And the distance between a hot dog and a sandwich is probably going to be the smallest of the three. And so what we're doing is that we're measuring similarities. A good embedding converts the input into a numeric vector of fixed length that captures semantic meaning. And vectors that are close to one another carry similar meaning. And there are many metrics that are available. And one of the ways that you can do this is that you actually train a machine learning model against a large data set of words. And then you don't care about what the outputs are. You use the weights that are generated in the inner layer when you input as your embedding. And it's that way that you capture the semantic similarity. And so when we talk about embeddings, this is what we're talking about. And when you go to API, when you go to services like OpenAI, they're actually going to give you APIs where you can hand it strings of words, and it'll hand back an embedding to you. And so that's how we're going to build our embedding vectors. The drawback of this is you look at these embeddings, and there's just like looking at it as a human, you lose all of the context. And so there are trade-offs for these things, but this is wound up being a very powerful solution for helping us translate real-world language into things that machines can do a better job of processing and understanding. So what we're going to do is we're going to take these embeddings, we're going to use fixed vector to represent the text documents, use our LLMs to compute the embeddings, and then we're going to put them into a vector database which maps the text that we have to the embedding vectors, and then we can do queries against this. And particularly what we're going to do is when we ask a question, we're going to create an embedding out of that, and then we're going to go to the vector database and ask for all of the text that closely matches the question that we ask. Right? Does that make sense? Did that help clear up?
This makes sense. Just
okay, yeah. Okay, so so the way that we're going to do some of these things is we're going to leverage open source libraries that exist right now, and that are kind of out there. And the first one that we're going to lean heavily against is LangChain, which is an entire tool set that is meant to help you build language applications against large language models. They provide a bunch of different tools for you to be able to do this. And so in our code, what we're going to do is we're going to use this concept of document loaders, where LangChain provides a number of different APIs for you to ingest documents. We're going to use its Git loader. We're going to give it a path that we're going to save the documents to. So we're going to save the documents locally. We'll clone the repository. And then we will load all of the data with every file that has a path that matches empty. So we're going to be loading markdown files. So if you're using RST as your documentation format, you would just replace the empty with RST. If you're using text files, if you want to pull the documents from somewhere else, like maybe you want to pull from Wikipedia or something, there are document loaders that will go and grab documents from different sources. But we're going to be using the Git loader. We're going to be pulling in markdown files because we document label studio with markdown. And then we're going to load the data into that. And then from there, we're going to use LangChain to process the data. Now, one of the things that we need to remember too is that large language models typically have context windows, and they have a maximum length of data that you can put into them. So we're going to try to chunk the data up so that we only worry about 500 character blocks. We're going to use OpenAI embeddings to provide all of our embedding vectors. The nice thing is again, using libraries like LangChain means that if we want to swap out to different embedding models, we want to swap out to different large language models, we can do that if we want. And we can even use embedding models that are different from the LLM that we want to use, right? Because there's not a tight, because we're looking for semantic similarity with the embeddings, and then we're going to use the LLM to generate text based off of that. And so you could actually use entirely different embeddings if you want. You can kind of mix and match these things. And we're going to use Chroma as our vector database. And by using Chroma, it just means that we don't have to worry about doing computations that are like computing similarity, and we'll be able to do searches faster. And so using other tools to kind of do all the heavy lifting for us. And so we're going to take this we're gonna split up our markdown text. We're gonna split the documents up and we're just gonna load them directly into the vector store with the embeddings that we specified. So with that, actually we can kind of go into the workshop part of this with kind of all of this background information and begin working on this. So let's start by building our bot. So let me see. So we can start this by going to this repository, this label studio examples. This is linked in the from the site that we have here, and we are going to download this repository. And we're going to go into this question answering system directory. So this is the directory that we're going to be working on. And you can see there are a number of different Python files here that we can look at. And there's also a README to help you get started. Now, we're not going to get to the point where we need Label Studio quite yet. That's going to be further in at the end of the talk. But I want to give everyone a little bit of a warning that that's probably going to be the most time-intensive part of this workshop, getting that installed. Just because depending upon if you're running Linux or Mac or Windows, the installation process may be a little bit different. Really, if you're going to be using Label Studio, if you're following along, I would suggest one of the easiest ways is if you have a Hugging Face account, go to Hugging Face Spaces and replicate the Label Studio space there and use that. It will probably be the fastest way to install it. But if you're on Mac, I suggest using Homebrew or Docker. If you're on Ubuntu or Linux, you're probably fine here. So I am going to actually remove this first line from requirements.txt because I'm going to run Label Studio in Docker. I'm also going to run this inside of a virtual environment. If you're familiar with Python development, I like to install things in virtual environments or something similar because I don't know what something's going to install, and I like to keep my working environment as clean as possible when I'm trying new things out. So running this virtual environment, creating that means that we're going to be, if we make mistakes or something gets installed that we don't like, it's easy to uninstall it, right? And we're just going to install these requirements. Right, live coding here too. And as you're working on this, if you have questions, feel free to ask. If you run into troubles, happy to work through this.
Which one did you remove from the requirements?
The Label Studio one. Yeah. And we can install it later if we want. Okay, so with that installed, the first document that I want us to look at is this build docdb. And so this is the code that we were looking at before. We're going to be using LangChain with the Git loader, the Markdown text splitter, OpenAI embeddings, and Chroma for all of this. This is going to take the longest amount of time. You're loading the repository that you're interested in. Label Studio is a pretty big repository, so it'll take a while to download it. Split up the documents, compute the embeddings, and load them into Chroma. This is provided this is wrapped up in main, so you can provide your own repo path if you want to, your own URLs, and you'll be able to work from that. So if we run this using, so we start with the help, we can just look at this and see how that works. And so we'll just build that using the defaults here. But you can use your own values if you want. This is the part that's going to take a little while. The source for this is if you go to this URL, label studio or the .io / PyData NYC. Yeah, so in Homebrew on the Mac, it's a package manager. You need to get application-specific packaging for it, so that brew tab command does that. Brew install human signal /tab /label studio. We'll install it and then you'll be able to run it. If you have Docker running, and if you search for install label studio, like there's a whole page here that covers this. But the key here is that you want to do this Docker run. You want to open up port 8080 because that's where the application is going to be hosted. Mounting this volume, I think, is actually for this event could be optional. But then you just use hardx labs /label studio latest, and that will get the latest version of Label Studio, and then I'll have it running on port 88. If you also go to Hugging Face, in creating their spaces, you can also use this. We have a Label Studio template to get you started. This is entirely free. We'll give you the right version, super fast.
I think that's
Yeah, and this will work fine for us too. Okay, so let's go back here. This is still slow. I probably should have preloaded this data before I did this. This is why sometimes it might be nicer to use it, but we've loaded the data. Now we're going to compute our embeddings and input it into the database. So this will take a little bit. Oh, the other thing that we need to do also is you're going to see that I'm going to run into an error here, and it's because I didn't set my Open API key, right? I need my Open API key to be able to compute the embeddings. So I won't show the Open API key, but you want to export this as an environment variable. You can kind of actually see a little bit there. I guess I will show my Open AI key. I'll cancel it at the end of the talk. That's the environment variable you want to use. And then if I rerun this, again, this build doc, it's not going to download, and we cache the repository, so it's not going to go and try to download it again. But now it's going to go out and it's going to start communicating with OpenAI to compute all of our embeddings and bring those into the database. And so that's our first step here. How's everyone going on this step? Is anyone running into any problems, or you're all able to follow along?
We're building a store down
Okay.
here. Dependency resolution.
Yeah. And I would, if you're running into the problem if you're running into dependency resolution problems, I would delete Label Studio from that line in requirements.txt and install it without, because we can use other things to get there. Okay, so if we look at this directory too, while you're working on this, I actually think it's instructive to just start up a simple chatbot that doesn't do anything like any of the training that we do there. And I like this because it actually shows you how easy it is to actually start up a chatbot. You import a few libraries, and so you bring in LangChain with the chat OpenAI model. You wrap it up in Gradio, so you build a Gradio application out of this. And you essentially just, create a prediction function, which is like, takes the input from your chat and then returns the output. And then you have a chat interface. And this code is essentially copy and pasted from the Gradio getting started guides. But it's the start for all of this, and so we can take a look at it. We can run this application. Give it a chance to start up.
Which file do you call the OpenAPI key? Because I have it in the file, so I want to read it from the file.
Yeah, I usually set it as an environment variable. And then
Yeah,
it should,
I understand, but in which Python file in your repository do you use?
oh, I just created a file and I have I'll show you here. In my home directory, I have an open API key file.
No, sorry. So my question is regarding, because I have my open API key stored in the file, I don't want to store it as an environment variable for whatever reasons. In which file in the repository, of the workshop repository, will we use the open API key so I can write this?
Yeah, all of them use it.
All of them.
Yeah, all of them are gonna use it. Yeah, so if we start this app up, so this is running locally. This is a Gradio app, and you know, what sort of question do we want to ask? We could ask anything, like, you know, how do I install Label Studio? You know, and it actually, you know, it takes a little bit. It's going to go out, get an answer, and come back. And it actually has it gives a pretty good answer. It tells you that this is correct. It tells you need Python 3.6. That actually is a pretty good indication of how old this is. I don't think Python 3.6 is even supported anymore. I think,
3.7 isn't supported.
yeah, so you can tell like the age of the answer there. But you know, for the most part, it's not a bad answer. So we can exit this application, and then we can look at what I'm calling my advanced chatbot. This is where we add information about the embeddings into it. And so you can see that we're pulling in our vector store. We build this QA chain. And so again, like, this is nice because LangChain has actually built up a lot of this for us, and so we don't have to do a lot of the work. We give it a model name. We give it the predict function. You know, and essentially we're using the the additional information from the Chroma database to be able to load a bit of context into the model. Right, and so you have you're getting the retriever there, so you're getting, that's how you're kind of feeding that context information into that. And so if we run this advanced chatbot, we'll give it a little bit of time to warm up. Ask it the same question. It actually changes quite a bit, and I think we might have changed the LLM model that we were using too. But it actually gives you a shorter answer, which may or may not be better. But this is based on the context, and so you can see, but it's not giving us that bad information anymore. Let's see if it understands. So now it understands that you need Python version 3.8 or better, right? So this information is already more up to date, and this is based off the documents that we fed to it. And so this, at the most basic level, is just like, you can do this for any application that you want. And indeed, I have seen tons of organizations that are starting to use this as ways to augment their support systems. We use it internally at Human Signal for to kind of help spread the load of helping our customers. We have a highly tuned chatbot that we go to, and sometimes people will go and ask the questions about that, and then they'll, if we have someone who, isn't as much of an expert, but they still want to help out one of a user or customer to be able to do that. And so this is becoming really popular. You can kind of see how simple it is, to get started, using this, how powerful these tools are becoming. 2 years ago, it would have been a completely different story building something like this. And I think this is some, pretty exciting. Okay. So the slides just have some docs on this, and Getting the repository, running the simple chatbot, make sure you export your building API key. We have these commands here. We built our doc database. We ran the advanced chatbot. But now I want to bring this to the next part of the talk, which is this is nice, but there's always room for improvement. And one of the things that I strongly believe in it is that although LLMs are incredible at doing all sorts of automated things, they still only get better when we provide them with some sort of human feedback and when we give them some sort of feedback. Like one of the reasons that ChatGPT has been so great was because they took these original GPT-3 models and they started doing a lot of reinforcement learning from human feedback on that. And so actually having a ton of people look at the outputs and rank the answers, and then using that to go back and build a model that could fine tune and kind of build these safer, more informative models. And I think this is always going to be the case. That if you're looking for a competitive advantage in this space, the better that you can embed expert knowledge and have that knowledge be evaluated, against like expert knowledge, the better off you're going to be. Because we keep lowering the bar of how easy it is to use these models, and the main differentiator is going to be how much human knowledge and feedback you can put into those. Okay. So as we were kind of looking at before, we saw some answers were maybe good, some answers were bad, some answers could be improved upon, and we want to incorporate this human expertise. Okay, so you can consider all of the different ways to do this. We talked about this a little bit earlier. An easy way to do this is actually to add good responses to the vector DB. This is actually what we're going to be covering for the rest of today. Medium difficulty, which will be an exercise for you to kind of do on your own, but you should be able to do at the end of this talk, if you look through the examples, is to curate additional documents to improve the bad responses. And then the hard is fine-tuning the LLM, where you collect a lot of data, you retrain, it's a complex process, and it's an expensive process. This is well beyond the scope of this talk. Okay, so how are we going to do this? Well, we're going to have our chatbot, and every time that we ask it a question, we actually want to capture the input and we want to capture the output so that we can evaluate it in some way. And the evaluation tool that we're going to use is Label Studio because it provides a natural way for you to build a number of different, if you're not familiar with what Label Studio is, it's an open source data labeling platform that lets you kind of pull in almost any sort of data that you want, create targeted annotation interfaces towards those. And so if you're bringing in images, you can have object detection in the images. You can pull in text and have sentiment analysis. You can pull in video and have frame detection. And you can mix human input, so annotators who are going in and saying that this sentence is, this person is being mean, this person is being kind, if you're doing sentiment analysis, or saying this is a picture of a dog, this is a picture of a cat, if you're doing some sort of object identification. In this case, what we're going to be doing is we're going to be bringing in the questions and the responses and having annotators label the responses either as good or bad, right? And then we're going to be using that to, bring in the good responses to kind of reinforce the sort of embeddings that we're getting back out from our chatbot. This is going to be done by using LangChain callbacks. And so Label Studio is integrated with LangChain as one of their callback mechanisms. And so LangChain will actually handle the gathering all the information and then sending the call to Label Studio and creating a new task for your annotation team inside of Label Studio. And then you'll be ready to label it. And so in this way, we're going to be able to improve the system. We create a feedback loop where users are constantly using the system, and then annotators are constantly evaluating the output from that and improving upon those responses. We can also use more advanced features to kind of understand the metrics. And so oftentimes annotators can disagree right? That's one of the good things about human feedback is you can have multiple people look at it. You can give scores. You can maybe annotators disagree, and you can use that as a means to further evaluate the effectiveness of the answers. But what we're going to do in this process is we're going to send responses to Label Studio. We're going to do the annotation. We're going to export that data, and then run a script that will incorporate those responses into our embeddings database. And then we're going to restart that up, and that's the process that we're going to use to improve the chatbot. In a production system, this would actually you would want to automate these things and kind of help build this into your ML pipeline. But this is just kind of an example to give you a taste of how something like this would look. Okay, so let's build a better bot. Okay, we're going to start off by launching Label Studio. Depending upon how you have it installed, there are a bunch of different ways that you can do this. I am going to run it through Docker. I have this running on Docker here, where I'm going to do Docker run, have it listening at port 8080, running the latest version of Label Studio. So we have this running here. I'm actually just going to create a new project. I'm going to call this NYC 23. Okay, so Label Studio has the concepts of projects. And in a project, you are annotating a particular type of data set that you're interested in. And when you first launch Label Studio, it's going to ask you to create a login. And then when you create your first project, it's going to give you a bunch of different options. And so you can see we have computer vision, natural language processing, conversational AI, ranking and scoring. We're just going to create a custom template for this, just so that we can walk through exactly how this works and kind of give you a feeling of how you build these labeling interfaces. It's all done through XML, which we have kind of just a bunch of different tags that you can use to build the interface out. If we head back to the repository here, we have the interface that we want to use right here. So this is the labeling configuration. We can just run through this really quick to kind of talk about what each of these means. You can embed styling inside of it, so you can make it look nice. We have a bunch of styles here. This is just standard CSS, which goes into this. We have views, which are kind of like divs in HTML. If you're familiar with HTML, you give it a chat container, and so it's going to be able to essentially give you a double type interface. You have different variables that are in here, and so for example, within your labeling data set, you're going to have a column named prompt. So every row in your data set is going to have some value in that prompt, and that's what's going to be displayed to your annotation team. Then there's going to be a response, and so that's the response that the chatbot gave back to it. This is also going to be a value. And that's just kind of in your data, and if you imagine if you're doing financial data, maybe you're looking at transactions, and so you might have a transaction ID, the value with with who it was at, or if you're doing images, there may be an image label that points to URL for an image that you're labeling, and so it's a super flexible interface that lets you kind of display a bunch of different things inside of it. But then we come down to here, we can give instructions. So this is asking the annotator to rate the answer. But then we have this down here, which is choices, right? And this is one of the input, one of the input parameters that you can give to your labeling interface, where your annotator actually gets to choose this is good or bad, right? And again, it's highly configurable. You could have neutral, you could have I don't know. and this will be written to the field to the name rating, right? Which is going to which is going to appear as one of the columns in our annotation interface. And you can see a preview of what that looks like. And so you can see that we have our prompt up here, our response down here, and then the annotation interface there. And so we're going to save this project. We don't have any data yet. That's what we're going to be doing with our latest chatbot. But the first thing that I need to do is actually, I need to get an API key for Label Studio, and I also need to know the URL that I'm doing, that I'm connecting to. If you're running on Hugging Face, you're going to have to look up the URL, make sure that your space is public to be able to access it. If you're running it locally, localhost is just going to work fine in this instance. But I'm going to copy this, and then if we come back to our example here, we want to export our Label Studio API key. Okay, so let's close our chatbot here. Okay, so we have that loaded into our environment. And then let's look at this chatbot file. And so this was the original chatbot that this shipped with. You'll notice it's very similar to what we had before. We have our vector store. So we're going to be retrieving this from. But we also, the thing that we want to note here is that we have this Label Studio callback. And so this is going to read our API key from the environment. Look at the URL, and then every time LangChain sees a response come in, it's going to make a call to this callback handler, and it's going to write a new task into Label Studio for our annotators to look at. And then pretty much everything else is just the same. Again, this is 60 lines of code, right? And a good chunk of those are just import statements. So if we run this version of our chatbot, so this was something too that we need to, there are actually more parameters that we need to set when we run this. So we already have our Label Studio API key as an environment variable, but we actually need to give it a URL that we want to look at, we want it to go to. So Label Studio URL, in this case, is localhost. We need to give it a project ID because it needs to know which project it has to write into. You can actually get this by, if we go back to our projects here. The easiest way to do this is actually to look at the URL up here. And you can see that there's a 16 up there, which is the project ID. We are actually working on improving the API to surface that a little bit faster, to also give a project ID by name. To be able to look that up, it's an improvement that's coming in. In our persisted directory, this is where we essentially saved our database, our embedding database. So now we have a new chatbot running. And if we come back here to where's our chatbot window? Okay, so we can ask, how do I install Label Studio? Right? We restarted our bot. We're going to ask it a question. We're going to get this question here. This one actually, came back and said that we make sure that we have Label Studio 3.8 installed before we do that. Then if we come back to our project and we hit reload, we're going to see that a new task has been loaded in there with the response that we have. And so we have the prompt, we have the response, and we can rate it as good or bad. And we'll say this is good, right? It didn't tell me anything wrong. Maybe it wasn't as complete as we wanted, but this can be a good answer, right? Maybe how do I? Right, we can ask a question, how do I install Label Studio in Cubase? It actually doesn't know, right? And so we can mark this one as, if we go back to our labeling interface, we can actually maybe mark the answer to this one as bad. We can see it there. So there's something a little funny is happening with the database on that. My demos are always kind of this way. But yeah, so we're going through and while we're working with the chatbot, we're able to do this. And this this means that you can actually have this thing running live. You can be exposing it to your users, they can be working on it, and your annotation team can be working in the background, like saying like, yeah, this was good, this was bad. And kind of going through and making these changes. Now when we're ready, like when we feel like the annotation team has done their, has like done a good job and we're ready to like start bringing this information back in, what we want to do is take what we consider the good answers and actually start bringing these back into our embedding database so that we have text that we know this contextually is, has like good context, has a good answer, and that we want to be able to help guide the responses from the chatbot even more. So you can export your data here. You export this as a, you can export this as a JSON file. And we can actually look at this. Okay, so it's for the JSON files. So we have project 16, which is the data that we output here. And you can just see that it's just, JSON file with like all of the data that we have there. So it's structured nicely, which means that you can kind of bring this in and introduce it to the rest of your pipeline. And so the call that we're going to use to do this is this add documents command, where we're going to parse the data from that JSON file. We're going to pick everything that's good, and we're just going to load that into our Chroma database. So we're going to go into our vector store, we're going to get our good examples, extract those, and then add those to our docs. Right? And this should give you a clue actually as to how you can improve this. Right? So a way that you should be able to improve how your annotations are even happening. Because if you think about it, like just saying that something is good or bad is just like a very basic level of feedback that we're giving to the system. An ideal level of feedback would be for someone to correct the bot for the bad answers, right? And say that, no, well, you should have answered this way. And we'll leave that as kind of an exercise to the user, but you should be able to kind of see how you might want to be able to build something that adds these things into here. So if you do Python 3, add documents. So we just want to make sure that we have, I'm not in, okay, so I just need to give it the JSON path. Oops, that's not what I want. Project 16. This goes through, it adds the documents, and then we can restart our QA bot. Now this is one of the questions too, is like without a lot of data, it's actually hard to evaluate, like, is this helping or is this not helping? But when we shut this down and we start it back up, we're going to start it's back up with that one new embedding that we've added about whether the answer was good for installing Label Studio. Okay, so incorporating human feedback is going to be a part of almost every ad. system. Yes, you had a question?
So, quick question. When, like, for example, the API returned, I don't have the answer for this, was that just OpenAI summarizing the results from the vector DP? Or is there some kind of processing from like LangChain in the middle?
Yeah, so I don't know actually. Like I know that like so what's happening behind the scenes is LangChain is going to the Chroma database and collecting all of like whatever the top like 10 documents or whatever it is that it feels like provide the most context, and then they're feeding that into the context window for OpenAI. And I think that when you provide a context window, that OpenAI actually tries to use it. But I'm, you know, so and if it doesn't have, I've seen this before where it actually says that you haven't provided enough context for me to answer this question. So I think that's actually, you know, that's happening on the API side, and you know, if you just ask OpenAI directly about it, I don't know if it would give you an answer. I mean, we could actually run the symbol one and actually find out if we, you know, if we wanted to.
I mean the return, sorry, of the one that you showed on the screen where you
Yeah.
question.
Yeah, but I think that has to do with the context when we fed into OpenAI. Like I think that's what part of what caused it to say that I don't have enough information to be able to answer this. Yeah. So you know, these are very general tools. Like you know, not that much code. You got a lot of power into it, but this is a way that you can start introducing, you know, callbacks and annotation into, you know, kind of into really into a, you know, into a better workflow. You know, so the challenge is that I kind of actually, you know, think that if you work through the examples and you start going through this, and we have about, I don't know, 20 minutes left or so for this talk, is like, how can you build a bot with better feedback, right? How can we incorporate better human feedback into the system? So, you know, like kind of the key hints are here is that you would need to update your label configuration to incorporate human feedback into the bad answers, right? And then you would need to modify your processing script to write the feedback into the vector database. And so recall that when we were giving, you know, remarks something is good, we just took the responses and we just wrote that back out as context for the database. You know, but taking these fields and then saying, okay, is the answer bad? You know, what is the feedback on this? And then taking that as the context to be able to do it. That way you're not just taking the feedback for the good answers, but you're taking the feedback for the bad answers. And you could, you know, so like, you know, for example, on the Label Studio side of things, that might mean going into your settings and going into your labeling interface. And we have a whole list of like, you know, APIs for you to be able to, you know, kind of add new tags into these things. But like, you know, maybe you wanted to add, say, I think there's a text label tag. Point label, no labels. Anyway, yeah, we can. We want to find your text label tag to be able to add into the interface. Yeah, right there. You would have a. Oh, that's actually the text name. Anyway, I would have to. Actually, a clue could be to, if we go to the general. Anyway, I don't want to dig too deeply into this, so I don't have the time we have. But yeah, that kind of brings you to the end of the workshop, to the end of the talk.